So here is our first example of solving a force problem. On a side note, it's possible I might have done this problem in a previous video. I apologize if that's the case. You can skip it now if I did. But since I can't remember, I want to go ahead and solve it so that we have practice. So we have our person weighing 700 newtons. Now remember, weight is another way of saying force of gravity. So we can say that mg for this person is 700 newtons. Newtons, again, is the SI unit for force, which, recognizing that, we should be able to tell that this is a force and not the mass. This person is riding in an elevator. It has a downward acceleration of 1.5. Excuse me. We want the magnitude of the force of the elevator floor on the person. So since we're talking about the person, the problem is asking about the person. My free body diagram, again, this is number one step. Free body diagram, every object we talk about right now is going to be a dot. We need to recognize and draw the forces on this person as our object in this case. So we know there is a force of gravity. I'm just going to label it mg. You can label it as F sub g or W for weight. We know there is the floor of the elevator pushing upwards on the person. And this is a normal force because it's a surface pushing. There's no other forces acting on the person. There's nothing else in contact to produce a contact force, so there's no other push or pull. So we are currently done with our free body diagram. If we write out either acceleration is equal to net force over mass, or the net force determines the acceleration, so net force is equal to ma. Either way, we need to write the net force in terms of the forces we know are acting on this person. So if I use a traditional Cartesian coordinate system where upwards is positive, I would say the normal force being upwards minus mg, because that points downwards, that represents the net force on the person, specifically in the y direction, which there are no forces in the x direction. So either way, this net force needs to go into Newton's second law, whichever way we would like to write that. This is just the preference. I'm going to go ahead and put it on the right. So my net force I know is N minus mg. That has to equal the mass of this person times the acceleration of the person. This is what I mean by writing out symbolically Newton's second law. And had we plugged it into the left equation, that would be perfectly valid as well. The only difference on the left is we would end up with N minus mg put in for the net force, divide by mass, and that would equal acceleration. So these equations are the same, just rearranged algebraically a little bit differently. In this particular problem, I'm going to revisit what we know. So it was told us that the weight of the person is 700 newtons. So mg, the force of gravity, is 700 newtons. I can actually put that in for mg here in my equation. Lowercase n is the normal force, which is what we're actually asked for. It wants to know the magnitude of the force of the elevator floor on the person. So we're looking for n. We're looking for the normal force. So I need to finish plugging in what I know. Mass of this person, I don't directly know, but if I know the weight is 700, then the mass is 700 divided by 9.8. So I can put that in for M. And anytime you see G, we're still talking just the magnitude of the acceleration of gravity. We have already accounted for the direction of the force with the negative sign. So we don't want to put a negative value of 9.8 because that would essentially tell our equation that gravity is pushing upwards. So we're accounting for the directions of the forces as we write out the net force. So whenever you have G, go ahead and just use 9.8. Now the other value we need here is the acceleration. The problem has told us that the acceleration is 1.5 meters per second squared, but it also has told us it points downward. So again, same coordinate system, downward's going to be a negative acceleration. So for acceleration, I will be putting in negative 1.5. Well, now we have all the information, and we can go ahead and plug through. I'm getting 592.9. Let's see. I'm going to say that the 700 is exact. I don't know for sure. Technically, we would want the decimal place. The 1.5 for sure is 2 sig figs. So 590 newtons is how hard the elevator floor is pushing up on this person. This is less than the person's weight. We should be able to reason through that. If you think back to the conceptual questions we went through, in order for there to be a downward acceleration, the net force also has to be downward. The acceleration direction is always the same as the force direction. So the only way to get that net force down is if mg is bigger than the normal force. So it's good to kind of reason through your answers and make sure they're making sense. So watch for the problem-solving technique as you go through these examples, and follow the technique as you continue working problems, the homework and practice.